Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Afif. Saya dan Muhammad Fazli akan menerangkan tentang DC shunt motor. Okay, introduction. Okay, first, parallel circuit ni dikenali sebagai shunt. Okay, yang kedua, armature and field winding dia connect dalam parallel connection dan dikenali sebagai DC shunt motor. Okey, yang ketiga, dia series wound DC motor and DC shunt motor ni dia punya construction wounding dia lain. So dia ada beberapa difference lah antara dua motor tersebut, dan antaranya adalah macam speed karakteristik dia ni berbeza. Okay, yang keempat ialah DC shunt motor is able to maintain a constant speed. Okay, DC shunt motor ni dia bila dia bergerak, dia boleh bergerak, operate, dia speed dia constant. Tak kisahlah load dia apa, dia tak macam series motor. Sebab kalau series motor dia macam semakin load makin besar, semakin tu dia speed dia makin kurang, lebih kurang macam tu lah. Okay. Armature and field shunt winding of a DC shunt motor are connected in a parallel circuit macam saya mention tadi. Okay, yang kedua, current dalam circuit DC shunt motor ni dia terbahagi kepada dua part. Okay, dua part iaitu satu, current through the armature dengan current through the field winding. Ni antara ni current dia lalu sini satu and lalu sini satu, so ada dua. So dia punya total current dia, I total dia kira jumlah dua ni, so itulah I total dia. Okay, so parallel circuit ni dikenali sebagai shunt circuit macam saya cakap tadi. And so daripada shunt tu, kita pakai shunt tu sebagai motor yang kita guna sekarang. Maksud istilah shunt tu lah. Okay, so saya akan menerangkan working simple dia. Okay, satu, yang first, stator dia punya ataupun shunt winding dia. So stator ni dia punya besar, bahagian besar dia ni, dalam ni rotor. Okay, so kita macam pasal stator. Okay, stator ni dia voltage supply to shunt. First dia punya proses dia ni voltage supply to the shunt winding of the motor. Okay, dia nak cakap shunt winding ni dia buat daripada beberapa coil lah dalam ni. So dalam ni ada beberapa coil, tapi dia punya wire dia macam nipis je. Okay, wire dalam ni. Okay, ni field winding ni dalam ni. Okay, yang ketiga dia nak cakap dia betul dia cakap mention tadi wind wire dia size dia kecil je. So macam dia tak sama macam series motor winding lah. Macam kalau series motor dia punya size dia besar sikit. So dia punya shunt DC ni dia tak boleh carry current besar macam series punya. Okay, kita sambung. Okay, yang kedua, rotor yang saya mention tadi, yang motor dalam dia ni. Okay, ni rotor. Okay, so first the rotor dikenali sebagai armature, lebih kurang lah. Okay, so dia handle the shaft load. Maksudnya shaft ni yang bergerak ni, so dia ni antara shaft ni lah, ni shaft, ni rotor dia. Okay, so dia punya tengok wire kat sini. So dia besar daripada wire tadi, size dia lagi besar. So dia punya current support dia kat sini lagi tinggi lah. Okay, lepas tu dia cakap high current pass through the armature during the motor start up or when the motor is running at lower speed. Maksudnya dia cakap maksudnya bila start motor, So dia punya current dia tinggi, tapi dia punya kelajuan running dia dekat dalam keadaan slow lah. Okey, so bila kelajuan dia makin meningkat, so dia punya gerakan ni, bila dia ni meningkat, kelajuan dia meningkat, so dia macam akan menghasilkan ni counter electric magnetic force. Yang ini kita bincang lepas ni. Okey, so next. Okey, sekarang commutator. Okey, commutator ni dia commutator ni kat sini. So dekat dalam commutator ni ada brush. So bila motor ni bergerak, kat sinilah yang akan terhasilnya current. Okey, provide current from the static wheel winding to the rotor. Okey, bila dekat bergerak, so bila motor ni bergerak, so dia macam menghasilkan current lah daripada brush and commutator ni. Okey, so bila dia bergerak pun torque akan terhasil, by the interaction of the magnetic field of the winding and armature. Okey, ni kita bincang lepas ni juga. Okey, so sekarang saya akan menerangkan proses dia. Okey, first bila motor ni on, so DC voltage supply to armature and field system. Okey, so DC, dia supply sini. Okey, voltage current semua masuk sini. Okey, ni dia. Okey, lepas tu when voltage applied, the circuit produce a magnetic field between armature and the conductor on the armature has different current flow. Okey, ni maksudnya bila dia voltage dah supply, so dia akan menghasilkan ni magnetic field kat sini. So yang second, dia akan menghasilkan ni dalam ni bulat ni konduktor tau. So dalam dia ada macam current flow tau kat situ. Okey, next. Okey, sekarang proses kedua yang saya mention tadi, ni yang konduktor yang saya cakap tadi. Okey, yang bulat tadi kan. Okey, first dia ada dua bahagian tau. Bila dia bergerak, bila supply voltage tu, bila supply sini, dia ada dua bahagian. Satu bahagian yang pertama ni, yang X ni, yang bahagian pertama ni dia cakap conductor on the left side indicates that the currents enter the conductor and creates a rotating field in the clockwise direction. So maksudnya dia kat sini X semua ni, dia current masuk conductor ni. So bila current masuk, dia punya rotating field dia akan ni bergerak mengikut arah jam. Okey, ni yang bahagian yang pertama. Okey, ni bahagian kedua pula. Bahagian kedua, dekat conductor on the right side indicate that the currents leave from the armature conductor and creates a rotating field in the anti-clockwise direction. Okey, maksudnya dekat sini pula, yang bahagian kedua pula, dia tak sama macam ni. Dia current dia keluar daripada conductor ni. Bila current dia keluar, dia punya rotating dia bila sekejap saya lupa pula ni. Okey. Bila current dia keluar, dia akan ni bergerak, rotating dia mengikut arah arah lawan jam. Okey, begini ni, macam ni. Bila current dia keluar. Okey, ni bila dia masuk tadi, okey, dia macam ni, dia punya current flow dia. Dia punya rotating field dia. Okey, next. Okey, ni proses yang ketiga. Okey, changes in magnetic field. Okey, after interaction between the flux and armature cause that flow of the magnetic field change. After that, it will make the armature or the rotor move in anti-clockwise direction. Okey, maksudnya tadi kan saya ada mention tadi, conductor dalam ni dia kan ada rotating field masing-masing kan. Macam belah ni dia belah ni lain, okey, belah ni lain. Okey, tapi yang first tadi dia punya magnetic field dia kan straight kan. Okey, bila maksud flux ni bila dia dah ada interaction between magnetic field yang straight tadi dengan conductor yang first tadi, bila flux antara interaction flux dan armature cause the flow of the magnetic field change. Okey, maksudnya bila dah ada interaction tu, dia punya flow dia akan berubah daripada straight tadi ke macam ni. Dia punya flow dia akan berubah lah. Okay, so bila dah berubah macam ni, dia punya flow dia, flow magnetic field dia berubah. So dia akan menggerakkan motor. Okay, dia kan macam ni kan. Okay, so bila dah lama-lama, dia motor ni akan slowly bergerak. Dia mengikut dia punya arah pergerakan magnetic field ni. Okay, dia bergerak, dia mengikut anti clockwise. Dia ke sini macam tu. So sebab dia punya flow dia macam ni kan. So dia makin lama makin macam tu. Dia macam tu, diikut anti clockwise. Okey, itu saja proses motor, pergerakan working principle motor. Okey. Okey, sekarang saya akan menerangkan tentang application dia. Okey, decision motor ni dia punya dia punya karakteristik dia, current dia constant tau. So macam current dia constant maksudnya current dia stable lah. Okey, so antara beberapa application yang required ni current stable ni, speed stable ni. So antaranya adalah satu, yang pertama centrifugal pumps, yang kedua lift, yang ketiga blowers, yang keempat fans, yang kelima conveyors. Okey, ni antara salah satu application yang menggunakan motor yang kena ni lah, speed stable lah, speed constant ni. Dia tak adalah macam tiba-tiba laju apa semua. Dia stable je. Okey, itu adalah application DC shunt motor.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good morning. So, my name is Fazimuddin. I will continue what Afia has said. So, I will tell about decision motor, speed torque characteristic, and for the equation. Okay, first, this is just the construction for DC motor. So, you can see the connection to the motor. Okay, speed torque characteristic. So, torque is directly proportional to the product of flux per pole and armature current. So, the torque is parallel to the armature winding because of the same supply voltage throughout the motor. Next, torque increase with the increase in load current. So, when the load current increase, so also the torque also will increase. Same as the load current, as they have the same voltage. Next point is weakening of field due to armature reaction cause the torque line to drop slightly. So when the field is weak by the field, when the field is weakening due to armature, so the torque will drop slightly because of the reaction to the armature. So we can see the graph. So when the speed increase, so also when the speed is increased, so here you can see the torque is dropping here. And for the second picture is first when we start motor, the in the middle of the movement, the motor will slightly slow down because of the torque, and then it will continue to stabilize. So next is for equation for speed and torque. So first, IA equal to EB over RA. RA is armature current. So when we want to find armature current, we should with EB over RA. That is, RA is armature resistance and EB is back EMF. So voltage is equal to the IARA voltage drop plus back EB. So V equal to IA times RA plus EB. IA will equal to I total and ISH. So voltage equal to EB plus I total minus ISH times RA. So the field current is the ISH is the field current. ISH equal to V over RSH. The RSH is the resistance of field winding. The field current remains constant for a fixed period. So it has explained here. The decision motor is when the motor is stabilized, so the speed will remain constant. So we can use the motor for the application that use constant speeds, such like centrifugal pump, fan and conveyor that is used for a long time.
Okay, I will present about DC motor separately excited. Okay, this is the speed characteristic. The speed of DC motor is proportional to back EMF or flux. The meaning of back EMF is voltage. The back EMF is the term that we use for voltage in this situation. The next one, when the load is increased, back EMF and flux will decrease due to armature resistance drop and armature reaction respectively. So when we are inserting the load, the voltage and the flux will decrease a bit to the armature resistance. So the armature will react when the load is inserted or when the load is increased. The next point is back EMF decrease more than pi, so that the speed of the motor slightly decrease with load. So the voltage will decrease if the voltage is more than the flux. So the speed will slightly decrease with the load. The next one is torque characteristic. Torque is proportional to the flux and the armature current. Neglecting armature reaction, the flux is constant and torque is proportional to the armature current. So when the armature has failed, when the reaction of armature is failed, so the flux will maintain. The flux and the torque will maintain, and it will proportional to the armature current. So this type of motor does not start on heavy load. So as you can see here on this diagram, the number one is the armature reaction neglected. So when they have no load, the armature reaction will fail a little bit. But when the load have been inserted, the armature reaction has taken into the consideration. So when the armature reaction through cross magnetizing system is followed by demagnetization due to the saturation, the effect of demagnetization on the field flux into the armature flux, we can see on this diagram. The speed drop from no load to full load. Here, the number one, we have no load, but the number two, when we insert the load. So the speed drop from no load to full load, it will improve the speed regulation. The next one is the equation of DC motors. As you can see here, the first point, the armature current is equal or same as line current. So the next point is back EMF developed. So the equation is EB equals to V minus by R, where the voltage is the supply voltage and the RA is the armature resistance. So EB is equal by voltage is minus then the current and the armature resistance. The next point is the power drawn from main supply. We can use here P equals to I multiplied by V, which is current multiplied by voltage. So the last point is a mechanical power developed. This mechanical power developed, we can calculate it by using the power input to the armature, we minus with the power loss in armature.
Okay, I want to explain about circuit diagram and working principle of DC separately excited. Okay, so this is the diagram of DC separately excited. Okay, usually in other DC motor, the field coil and the armature coil both are energized from a single source. Okay, single source. Okay, but first thing that we need to know, separately excited motor have separated field winding. That means supply to armature, yeah, is different and supply to field also is different. Okay, so here the field coil is energized from a separate DC voltage source and the armature coil is also energized from another source. Armature voltage source may be variable, but independent constant DC voltage is used for energizing the field coil. So those coils are electrically isolated from each other, and this connection is the specialty of this type of motor. Okay, so motor speed motor speed can be controlled by varying armature voltage or by varying field voltage control. So we can know that the speed control of separately excited DC motor is very well. Okay, next I will explain about the application of DC separately excited. DC separately excited, these have industrial application. They are often used as actuator. Okay, this type of motor also is used in train and also for automatic traction purpose. Okay, so we can conclude that by separately varying the field current, variable speed can be achieved. So this is the main reason why this type of motor is chosen, because we can obtain very accurate speed by using separately excited DC motor. And the last one is this motor is most suitable for the application requiring speed variation from very low value to high value. Okay, that's all from me.
Feeling good, like I should. When in dark, walk